Alright, here you're told, well, what if the extra sensory perception ability of people was such that they could predict the card on the bottom of the deck with an accuracy of 0.03, so above chance. Eventually you'll have to say what the odds are of you being able to detect this probability, or detect that the individuals in your sample are in fact better than chance, given that this is true. Now, for the first part of this question, what you're asked to do is convert the boundary into a z-score with respect to the probability density function for the research hypothesis. So you know that this distribution corresponds to the research hypothesis, where the probability of guessing correctly is 0.03, and you know that this value BR here corresponds to the proportion of individuals who would have to guess the card correctly in order for you to reject the null hypothesis. So if for this p hat value, which we computed up here somewhere, okay, this is the value. What is the z-score under the distribution whose mean value is 0.03? So what you have to do is take the value for which you would reject the null and figure out what z-score that corresponds to when the p hat is actually equal to 0.03. So this is 0.03 here. Okay, p hat is the value corresponding to your rejection region. Everything else is the same, so the z-score that we have now is equal to minus 0.8246, and you're asked to round it to 2 decimal places, so it's minus 0.82. Okay. Find the probability of a z value such that find the probability of a z value that is greater than the z value corresponding to that critical value, assuming that the research hypothesis is true, and this is obviously the power of the test. So the z value that we entered was minus 0.82. The probability of getting that z value or greater, you can find that here. It is equal to the non-shaded, non-colored region of the z distribution, so 1 minus 0.2061. That is the probability of getting a value higher than your critical value for the null distribution. So in other words, if the probability of guessing correctly is actually 0.03, when you're conducting this experiment with 1,830 people, assuming the null is true, there is a 79.39% chance that you will reject